Routing in sensor networks. So, this topic also we have divided into two parts. So, first we are going to go through some of the basics in terms of routing, the important concerns of routing in sensor networks, what are the different specificities that are there, and then we will look at some of the protocols, some of the sensor network specific routing protocols that have been proposed and the ones that are quite popular and popularly used in the community. So, when we talk about sensor networks, we have a scenario like this. What we have are different sensor nodes. Different sensor nodes may be, in this particular example, as we have seen that these sensor nodes, they are all sensing the humidity of the region, and the humidity is sensed by the sensor nodes, and through a multi-hop path, the sensed data is sent to the sink node, and from the sink node, the data are sent over the internet to the end user. This is a common typical scenario of deployment of sensor networks. So, what we see over here is we have a source node, and through this multi-hop path, the data is sent to the sink node. So, the routing issue is that how do we know which path the sensed data is to be sent through. So, one possibility is that it could be sent via the path that is shown over here to the sink node, or the other possibilities could be maybe from here it could have been sent here, then maybe here, then here, here, like this, and so on. So, like this, actually if we look at more carefully, there are different possibilities of sending the sensed information from the source node to the sink node. So, how do we send? What should be the path? What should be the route is what a routing protocol has to look into. So, this is what the different routing protocols for sensor networks basically try to resolve, that what should be the route through which the sensed data that is sensed by a particular source node is going to be sent to the destination node, the sink node. So, we will look at different routing protocols that have been proposed for sensor networks, but one thing I would like to inform to you that particularly in the case of routing, and and also it is applicable for other protocols that have been proposed for sensor networks, is that it is generally assumed theoretically that the unit disk graph model is followed by these different networks. Now, mind you that this particular concept is a theoretical concept, which basically says that the sensor nodes would define a particular unit disk graph around them, which means that there would be a corresponding to every sensor node, there would be a circle, a unit radius circle around them, which corresponds to the communication range of that particular sensor node, and it is a circle. So, this is a theoretical concept and it is a unit radius circle. So, as per this unit disk graph model, the sensor nodes define a unit disk graph UDG V, in which there is an edge between two nodes if and only if their Euclidean distance is at most 1. And I think I do not need to elaborate this, because this is fairly simple and clear to understand. And most of the theoretical literature on sensor networks, and more specifically routing in sensor networks, assume that the UDG is a connected graph, and this UDG model is good for use in theoretical solutions, because that way we can have different solutions to be modeled much more easily, but in practice actually the UDG model is not perfect and is not used and is not practical in most of the actual deployments of sensor networks. And in fact, it might also so happen that the transmission ranges of the different sensor nodes might also be different, and they may not all be the perfect disks due to environmental factors or different other reasons. However, as UDG is a theoretically simple concept, it is still used widely in the sensor networks literature, particularly the theoretically oriented sensor network literature. So, if we look at this particular figure, so what we have a source node which has a transmission range like this, and within this transmission range, which is basically which denotes the unit disk graph model. In fact, within this transmission range we have different other nodes like shown over here. And from this source node through a multi-hop path, the sensed data can be sent to the intended destination node or maybe the sink node. Now, the problem is like this, that these intermediate nodes will have to relay the packet that each of them receive individually. So, what we have is that we have multiple options for sending the packet. One is basically shown using the red color. This is one option, but there were other options like this path, which could have also been adopted. Likewise, there are different other paths which could have been adopted as well. So, how do I know? How do I know that which path the source node which has sends the data, through which path it is going to send the packet containing the sensed information? How do I know? So, basically a routing protocol will basically determine and enforce that particular path. Now, how do you perform routing? So, routing can be performed with and without position information. So, traditionally with a bare basic sensor node, what we can do is these nodes, they can discover who are their neighbors once they are deployed and they are turned on. So, we can we can enforce different algorithms, we can basically have different algorithms which will make these sensor nodes to discover their neighbors. So, through the discovery process, these nodes, they know who are their different neighbors, and that way any sensor node which is acting like a source node can send the packet to the neighbors, and from the neighbors further on until the packet reaches the intended destination node. However, currently, because of miniaturization, because of MEMS technology and very reduced cost of GPS technology and so on, nowadays the sensor nodes at very low cost, they can come equipped with GPS, and if they are coming equipped with the GPS, you can get the exact geographic location of the deployment of each of these nodes at a very low cost, and that will help the sensor nodes to determine their respective positions, and that that information can be harnessed, can be used by the different routing protocols for transmitting the packet from the source node to the destination node. So, it has been shown that if the GPS information, the exact geographic position location information of these different nodes are known, then routing can be performed much more efficiently compared to when this position information is not known. But at the same time, it is not that we need only the GPS based ones or the the ones without. Some hardware does not come equipped with GPS, in which case you have to perform routing without the position information known a priori, and in other cases, if the position information through GPS is known, then routing can be performed even more efficiently. So, both of these classes of protocols are required. Now, as the kind of sensor networks that we talk about belong to the ad hoc networking category, so we can use the AODV and the DSR protocols that were proposed, that are available for use of routing in ad hoc networks, and we have already seen that when we discussed about routing in ad hoc networks. AODV DSR are very popular routing protocols that are used in these networks. In fact, there are different implementations of sensor networks, the commercially available ones, which basically do not go for any sensor network specific protocol, but they just use the AODV or DSR protocols in their implementations. So, that is perfectly fine, because AODV and or DSR will work in a multi-hop network, and sensor network is a multi-hop network. So, in these protocols, the source node basically discovers the routes through short message exchanges, and then consequently what happens is, once the routes are discovered, the data can be sent through the discovered path. So, one possibility is that we can go for the by adopting these ad hoc network routing protocols, AODV, DSR or the like. The other possibility is that we can go for flooding based protocols, and in flooding based protocols, as we can see over here, the source node, it broadcasts the message to the neighbors. The neighbors are all going to have the copy of the packet. This neighbor will also have, and it is then going to send to its neighbors, and so on and so forth. Finally, a copy of the packet that was sent through this particular path is going to be reached over here, and because it is the shortest path over here, this path is going to be reinforced, and all subsequent packets that are sent from the source node are going to be routed through this particular path. So, this is route discovery through a flooding based approach, which can be adopted in the sensor networks as well. But can we do something better and more specific for sensor networks, given the different constraints, energy constraints and the different features, for example, data centricity? So, can we harness those things? Can we propose routing protocols that will be more specific, catering to the more specific requirements of sensor networks? So, we have data centric routing protocols, which basically use the data centricity that is inherent to the sensor networks. So, as you have seen that when we talk about sensor networks, it is all about sensing data, sending data, handling data and so on. So, it is all about data exchange between different nodes and so on and so forth. So, the data centric routing protocols, what they attempt to do is they attempt to harness the names that are associated with the data and use them for making the routing decisions, and not actually go by utilizing the specific addresses like the IP addresses associated to the different nodes. So, if we did not have, in other words, data centric routing protocols, what we need is some kind of addressing mechanism, which means that different nodes would have different specific addresses associated to them, like an IP address or something of that sort, and routing will be enabled by virtue of use of these addresses to identify how and where the data has to be sent from a specific point onwards. Data centric routing protocols, on the other hand, do not require the use of IP addresses or the like, and what they say is we will exploit the use of names that are associated with the data, and we will use them for making the routing decisions. So, there are different prominent examples of data centric routing protocols. Flooding and gossiping are two popular ones. Likewise, we have the SPIN protocol, sensor protocols for information via negotiation, SPIN protocol and the directed diffusion DD protocol. SPIN, as we will see, also has different variants of it, SPIN 1, SPIN 2, SPIN this, that, etc., and so on. So, these are basically different improvements over the originally proposed SPIN protocol. So, let us look at some of these protocols in more detail. Flooding and gossiping, I do not need to elaborate on them further. Flooding is a well known concept of routing, Gossiping is, you can construe gossiping as some kind of controlled version of flooding. So, where the receiving node forwards the data packets to a single randomly chosen neighbor, not to all the neighbors as in the case of flooding. So, it is a controlled form of flooding. But there are different limitations of use of flooding or flooding based approaches like gossiping. There is overlap of data, and flooding based approaches are resource blind. They will simply keep on forwarding data to the neighbors and so on without taking into consideration that whether the nodes have sufficient resources available with them or not. So, this kind of solution are not very ideal for use in sensor networks. We need something better. So, what is this better? So, spin protocol came to our rescue. So, in the spin protocol, the idea is like this, that we have a set of different nodes like the ones that are shown over here, A, B, C, D, etc. till H in this particular example. Node A, for instance, is the source node. It is the owner of the data at some point. Instead of sending the data to its neighbor B, what it will first do is it will first advertise, saying something like that I have a data with some kind of metadata like this. Do you, I am advertising to all my neighbors. Node A advertises to all its neighbors, B is the neighbor in this particular case. So, the node B, if it is interested based on the metadata that is supplied by A, if it is interested, node B will then have to request the data from node A. So, let us now go back and look at the slide, the particular figure. So, we see that in step 2, node B basically sends a request packet to node A, and then only thereafter node A in step 3 will send the data to node B. In step 4, node B has the data through the above 3 steps, it is in possession of the data. Then what it will do is it will follow exactly the same procedure that was done by node A in step 1. It will also advertise the data it has in the form of advertisements to all its neighbors. So, node C, D and E receive the advertisements in this example. So, in this particular case we see that both E and C, they request the data from B. So, B will send the data to both E and C as shown in this particular step. So, spin basically is a very simple and elegant protocol, the original spin, and there are different other protocols that have been proposed which belong to this class of protocols, the spin class of protocols, spin PP, spin EC, spin BC, spin RL and so on and so forth. There are so many different other spin protocols that have been proposed which basically follow more or less the spin concept of routing. So, I am not going to go through them here in further detail. It is for you to go understand. I mean, understand means like you can just go through this the different protocols. So, it is quite the different features of these different spin class of protocols are given over here, and they are very simple to understand. So, let me now take the help of an animation in order to understand this 3-step approach of spin that we have looked 2 slides back. So, let us go through it once again. So, node A basically what it will first do, it will send an advertisement to all its neighbors. Node B in this particular case is a recipient of this advertisement. So, then node B, it sends a specific request to node A for getting the packet from A. Node B receives the packet, the data, actual data. Then what node B does is it will send again the advertisement to all its neighbors. So, all these nodes that we can see over here, all these nodes are the recipients of this advertisement. So, they are going to send the request, whoever requests will send the request to node B. So, this is how it works, and finally, after this advertisement request data exchange, the packet exchange, the actual data will be sent by node B to all the requesters of that particular data for which the advertisement was made. So, the spin EC protocol is a very popular specific protocol, energy conserving spin protocol, which basically, as this name suggests, it adds simple energy conservation heuristic to the basic spin protocol and the spin PP protocol, which is basically a low energy spin protocol. So, it incorporates a low energy threshold and it works as the spin PP, which is again a very basic spin protocol where energy level is very high. So, so in essence actually I do not need to elaborate on this further, but as you can understand, the spin EC protocol is a very energy conserving protocol which tries to minimize to the extent possible the energy consumption of the different nodes that use this particular protocol for routing. Now, the other class of protocol is the directed diffusion. Directed diffusion, like spin and the spin class of protocols, is also a data centric routing protocol. So, the design philosophy is that you use the data centricity in different ways to get different variants, the two phase pool, one phase pool, push diffusion and so on. So, data centricity again is harnessed over here in order to route the packets. So, there are different so whether you are using this approach or the other, in general the DD approach consists of the following steps. First one is the interest propagation, second is message forwarding, third is gradient formation and fourth is reinforcements. So, these are the 4 steps primarily that are adopted by the DD protocol. So, as we can see over here, we have an example, we have a sink node and we have any node which can act as a sink as a source. The sink node basically propagates, it broadcasts an interest message to all the sensors in its region. The sensors create links that are gradients for reporting along the reverse direction as shown in figure B. Along the reverse direction, as you can see that the gradients are attempted to be created. Finally, through these 2 steps, the link is created towards a node with a smaller hop count. So, finally, what we have is, if the event has occurred in around this particular node, this node is going to report along these paths, and finally along these different paths that are shown over here. Finally, this least hop count 1 is chosen and the event will be continuously reported from this node towards the sink node. Okay. So, I hope that you can understand this approach. It is a very simple and elegant approach, a very popular approach, a very popular protocol. Directed diffusion is a very popular protocol like the spin family of routing protocols. So, let us look at this particular figure which basically clarifies how the 2 phase pool approach of directed diffusion functions. So, first, as we have seen before, is the interest propagation. So, the sink basically floats to all its neighbors and it broadcasts an interest message which will be propagated all through until it comes to the to a node which is the source node. So, source node is the one which will respond by saying that, let us say that let me take one specific example to make this particular point clearer. Let us say that the sink can propagate an interest by sending a message which says that can any of these nodes sense a particular object. So, then this will be broadcasted and it will be propagated all through, and let us say that this yellow colored node acts as a source node, because it indeed senses a particular object, and then what it will do is it will respond back along the reverse path. So, this is the gradient setup phase, and finally, So, along all these different paths, this interest is this gradient messages are going to be forwarded, and finally, the least hop count one will be reinforced as the path through which the data are going to be continuously sent from the source node to the sink node. So, there are different design considerations for directed diffusion with respect to the interest propagation, data propagation, caching and aggregation, reinforcement, and so on and so forth, and these are for you to go through. So, it is quite simple to understand. So, I do not need to elaborate on this particular slide. So, there are different advantages and disadvantages of directed diffusion. Although it is a data centric routing protocol where you do not really need to have any kind of IP addressing or similar kind of addressing approach to be adopted for routing, but there are different advantages of it, but there are different disadvantages as well. So, one of the disadvantages is that on demand query driven. So, this approach is inappropriate for applications that require continuous data delivery. So, example environmental monitoring. So, this is one disadvantage. Second disadvantage is that it is an attribute based naming scheme and is application dependent. For each application, it should be defined what that application is about a priori, and extra processing overhead at the different sensor nodes are required by adopting this particular approach. So, here is the list of references as usual. So, directed diffusion, the original paper and the paper that talks about it in more detail is available here. Similarly, the other other protocols like spin class of protocols and their corresponding references are also given in this particular slide. So, with this we come to an end of the first module, the first part of routing in sensor networks. As we will see in the second part, that there are many other interesting approaches to routing in sensor networks, and using which you can make routing much more efficient. So, this is what basically we are going to look at in the next part, the second part of routing in sensor networks. Thank you.